Hey everyone, welcome back to new series of Python. In today's video, we will discuss about the Python Bitwise operator. So Python Bitwise operators are used to perform the bitwise calculations on integers. The integers first will be converted into the binary format and then the operation will be performed on each bit. So that we will be getting the result and the result will be finally converted into the decimal format. And here we can just go with the Bitwise AND operator. So when you are just going with the Bitwise AND operator, we just need to consider the logical or the truth table of the AND operator, because the same concept will be applied for Bitwise AND operator, which means if both the inputs are 1, then we will get the result as 1, else we will get the result as 0. So let me consider here an example that A is equal to 7 and B is equal to 4. Now we just need to get the result. So as we just move on with the result, here we will get the result as 4 and that will be in decimal format. So if I want to just get the result, I'll be going like A and B. And let me first run this file, and here you can see that we have just got the result as 4. Now let's go to brief this example, which means that first we have to convert this decimal number into the binary format. So when you just convert the 7 into binary format, you will get 1, 1, 1 over here. And when you just convert the decimal form of 4 into the binary form, you will get the result as 1, 0, 0. So as you just go with the comparison using the Bitwise AND operator, here you will get the result as 1, 0, 0. So when you just compare 1 and 0, you will get the result as 0. Again, 1 and 0 will be 0. 1 and 1 will be 1. So here we know that the 1, 0, 0 is the binary representation of 4, and we have just got the result over here. Now let's move on to the Bitwise OR operator. So in Bitwise OR operator, we can just consider the truth table of the OR operator or logical OR. So in this case, we know if both the inputs are 0, then we will get the result as 0, or else we will get the result as 1. Now here we can just consider the same example itself. For that, let me copy this example and I'll be changing the operator over here. So I'm going to change the operator from AND to OR over here. So as we have a Bitwise operator over here, and when we just perform the Bitwise operator for A and B, here we will get the result as 7. So in this case, when we have 1 or 0, we will get the result as 1. Again, 1 or 0 will be 1 and 1 or 1 will result in 1. So we know 111 is the binary form of 7. And here we have just got that result. Now let's move on to the other example, that is the Bitwise XOR operator. So the Bitwise XOR operator, also known as exclusive OR, and it is used to perform the XOR operations on 2 operands. So in this case, if the bits are different, that will give the result as 1. Otherwise, it will be 0, which means that if we are giving the inputs, both inputs as 0, 0, like if A is 0 and B is 0, then we will get the result as 0. And if we are just giving the input as 1 and the other input as 1, then again we will get the result as 0. And if you're just inputting different bits over there, like 0 and 1, then it will result as 1. Now let's consider the same example over here. So I'm going to choose the example, and the same example will be taken over here, and let's go with that. And here we are just going to perform the XOR operator. So we can just change the symbol over here. So we have used the symbol and we will get the result as 3 over here. So as you just move on to here, you can see 1 XOR 0 would give a result of 1, and again 1 XOR 0 will again result in 1, and 1 XOR 1 will result in 0. So 0, 1, 1 is a binary form of 3, and here you can see that we have just got the result over here. And now let's move on to the Bitwise NOT operator. So in case of Bitwise NOT operator, The Python Bitwise Not operator works with the single values and it returns one's complement. This means that it toggles all the bits in the value and transforming 0 to 1 and 1 to 0, resulting to one's complement of the binary number. Now, let me just consider an example. Let's say A is equal to 10. And we just need to convert this number into the binary form. So, as you just convert the decimal number 10 or the integer number 10 into the binary form, you will get the result as 1010. And we just need to get the result over here. So, as you just move on to the results, you will get the result as 11 over there. But for the time being, it will be represented in negative form. So here you can just run the file and here you can have got the result. So here we just need to consider the ones complement. Okay. So in this case, you can say that we can just say we will consider the binary form of this number and we have to add 1 with that in order to get the result in one's complement. Now let's discuss about the bitwise shift. The bitwise shift operators moves the bit values of the binary object. The left operand specifies the value to be shifted. The right operand specifies the number of positions that the bit in the value are to be shifted. Now let's discuss the bitwise right shift. So this shifts the bits of the number to the right and fills 0 on the void left. So let's consider an example. Let's say A is equal to 10. So as you just convert this into the binary, you will get it as 1010. Now we just need to perform the bitwise right shift. So in this case, we will shift this and as we just shift, we will get the result likewise. The result will be 1, then 0, 1. Okay, we will be just avoiding this and this will be the result. So as we just shift this, here there comes a void over there. So there we will provide a 0. Okay, so as we make a shift over here, you can see that will be filled with a 0. And as you just go to the print, you will get the result as 5 over there, because we know that the result will be printed in decimal format. So if I want to just manage with the Python bitwise right shift, we can say that A, then we have to use the double greater than symbol. Then what we have to do is we have to just shift 1 bit from this. Okay, so I just want to perform only 1 shift over there. So let me run this and here you can see that currently we have just got the result as 5. Now if you want to perform 2-bit shift, you can also perform that. So in this case, if we are just performing 2-bit shift, then we can say this 1 will be removed from there and this will be the result. So we know this will be resulting in 2. So as we just run this here, you can see now we have just got the result as 2 as we just made bitwise shift of 2. Okay. And now let's discuss about the Python bitwise left shift. So this shift the bits of numbers to the left and fills 0 on void as a result. So let me consider an example. Let's say A is equal to 10 itself. So as we just convert this into the binary format, we will get it as 1010. Okay. And afterwards, or let me change the number from 10 to 5. That will be more better. And now let's print this. So we just need to perform the operation over here. So as we want to perform the bitwise left shift, you can just use the less than symbol. That is, you have to use double less than symbol. And I just need to perform the shifting of bit 1. And let me run this. And here you can see now we have just made the shift over there and we just got the result over here as 10. This is because we know when we just convert 5, so we know when we just convert the decimal format 5 into the binary format, it will be 0, 1, 0, 1. Okay. So here we will be performing left shift. Okay. So as we just move on to the left shift, here you can see you will get the result like this. So 1, 0, 1 and in the void, we will fill it with 0. Okay, so when we just fill that with 0, here you can see 1010 is the binary representation of 10. And we have just got the result over here. So that's how we just manage with the bitwise operators in Python. And that's all for today. Thank you for watching the video.